Hello everyone, in this video we are going to learn about quadratic inequalities. In here we have a quadratic function that is x squared minus x minus 6. We can also write it as x plus 2 times x minus 3, which means the root of this function fx is that x equals to minus 2 and x equals to 3. Now we can simply sketch this function. So here's the y-axis, this is x-axis. So hope you remember how to sketch the quadratic function. We can see that the coefficient of x squared, which is a, equals to 1, that is greater than 0. So the curve is a small face. And we have the roots that is minus 2 and 3, so which means the curve passes through the minus 2 and 3 at the x-axis, which means we have a graph look like that. So here is 3, here is minus 2. Well, when we want to see where fx greater than 0 or fx less than 0, we can see that when we see fx greater than 0, it is above x-axis. So it's this part, right? So we write that the solution of fx greater than 0 is the x values when the curve above x-axis. Well, how about fx less than 0? So that is the value below the curve below the x-axis. So this color, and it's when the curve below x-axis. We can see that the two important points is x equals to minus 2 and x equals to 3. For that, we call these values are critical values. In this case, we can use a graph to solve the quadratic inequalities. Now let's introduce the step. So the first one is that we need to rearrange the inequality that right-hand side equals to 0, and then solve the corresponding quadratic equation on the left-hand side. So why we need to do that? What we need to do, we need to find critical values. And then what we need to do, we need to sketch the graph of the quadratic function. To sketch the graph of the quadratic function. So unlike the linear inequality, we use the graph rather than the number line. And then we use the sketch to find the required set of values. Here is the process. Now let's move on to see some examples. So first question, it asks to find the set of values for which 12 over x greater than 3, where x does not equal to 0. One thing we need to be aware of that, we can see that x is in the denominator. So if x is less than 0, which means we need to change the sign. If when we need to change the sign, if we times x on the both hand side, but we don't know whether x is positive or negative. So what we can do, we can times x squared on the both hand side. Why is that? Because x squared is always greater than 0 for all real numbers. We can say it's never negative, because sometimes x squared equals to 0, so we said it's never negative for all real number x. So we need to times x squared on the both hand side. In this case, the sign stays the same. So we write that 12 over x greater than 0, and implies that 12 over x times x squared greater than 3 times x squared. We have 12x greater than 3x squared, and what we need to do, we need to rearrange the inequality that right hand side equals to 0. So we have 12x minus 3x squared greater than 0. And then the second step is to solve the corresponding quadratic equation, that is 12x minus 3x squared. So we have minus 3x squared plus 12x equals to minus 3x times x minus 4. Minus 4. And then we need to find the roots of this function. What we have minus 3x equals to 0, or x minus 4 equals to 0, which implies that the root of this function is x equals to 0 and x equals to 4. Let me write that. This is the first step. This is the first step. This is the second step. And then what we need to do, we need to sketch the graph of the quadratic function. As we can see, the coefficient of x squared is minus 3. So a equals to minus 3, which means it is less than 0, so it's a set face. And we know the critical value, that the roots of the function, one is 0, one is 4. So we know that the curve crosses at x equals to 0 and x equals to 4. And then we simply sketch that. The set face, and at 0, maybe this here is 4. So we probably lack the curve, looks like that. Sorry, not very smooth. Kind of look like that. And what the question asks you, that this function is greater than 0, which means the curve, you need to find the, let me use another color to write that. That means to find x values when the curve above x-axis. So where the curve above x-axis, so it's for this part, right? So it's when, that is the step 4, is when x less than 4 and greater than 0. So that is the solution. Let's see the whole process of this question. Now let's move on to the second question. So this question, for part A, it asks you to find the set of values of x for which x squared minus 2x less than 15. So the first step, for part A, the first step, what we need to do, we need to rearrange that. So the right hand side only left 0, that is x squared minus 2x minus 15 implies that x squared minus 2x minus 15 less than 0. And what we need to do, we need to solve the quadratic equation on the left hand side. So we want to solve that x squared minus 2x minus 15 equals to 0, which implies that x minus 5 times x plus 3 equals 0. So x equals to 5 or x equals to minus 3. And in this third step, we need to sketch the graph of this quadratic function. We can see in this quadratic function, a equals to 1, which is greater than 0, which means you have a small face. And then we can draw the sketch. We can sketch the graph. So x-axis, y, and there's the origin. And we have the maybe 5 over here and minus 3 over here. So the curve across x-axis at x equals to 5 and x equals to minus 3. And the small face, maybe the curve looks like such like that. Yeah. So not very smooth. Let me redraw it. Yeah, small face. And then what that question asks you that, so x squared minus 2x minus 15 less than 0. So in here, less than 0, which means x values when the curve below x-axis. And we know the critical value, one is minus 3 and 5. One is minus 3 and another one is 5. So the below the x-axis is this part. Right? Thus, we got the answer that x less than 5 and greater than minus 3. That is the answer. Now move on to the part B question. So what does the question B say? That hence find the set of values for which x squared minus 2x less than 15 and 3x minus 1 greater than 4. We have done the set of values for the first inequalities, and what we need to do, we need to find the set of values for this linear inequality. So what we do is 3x minus 1 less than 4. So 3x, it implies that 3x less than 5. Thus we got x less than 5/3. And the question asks you to find the set of values for which two inequalities true at the same time. Then we can draw the number line at this moment. So here is number line. There's 0. From the first inequality, which is quadratic inequality, what we get? We get x greater than minus 3 and less than 5. So we draw that. Here is 5. And here is minus 3. So it's this part, right? And then from the linear inequality, we get x less than 5/3. So it's around 1 point something. So it's here is 1. So maybe here is 5/3. And less than that, which means it's on the left-hand side of that. And the overlap area is between the minus 3 and 5/3, right? So this part. It implies that x less than 5/3 and greater than minus 3 satisfy both inequalities. Now let us move on to the question 3. The question said that the equation kx squared minus 4kx plus 5 equals to 0, where k is a constant, has no real roots. Prove that k satisfies the inequality that k less than 5/4 and greater than 0. From the question, we need to remember that no real roots for the quadratic equation means that the discriminant b squared minus 4ac is less than 0. And from the equation, we have that a equals to k, b equals to minus 4k, and c equals to 5. And we substitute them into the discriminants. What do we get? We get minus 4k squared of that minus 4 times k times 5 equals to 16k squared minus 20k. And since the question said there is no real roots, which means 16k squared minus 20k less than 0, which implies that 4k times 4k minus 5 less than 0. Right? And then we need to solve the left-hand side, which means you need to solve that 4k times 4k minus 5 equals to 0. We have the critical values. One is k equals to 0, and another one is when 4k minus 5 equals to 0, so k equals to 5/4. So we got the two critical values. One is 0, one is 5/4. And then we need to draw the graph of that. So we have a, so new a in this quadratic function, we have a is equals to 16, that is greater than 0, which means you have a small face. So small face a equals to 16, greater than 0, that is a small face. And the critical values, the roots of this function, remember this one, is 0, so here 0, and maybe here is 5/4. So x and y, and then the curve of this function will look like that, right? And then we want to find the x values, that is 4k times 4k minus 5 less than 0. So less than 0, which means x values when the curve below x-axis. So where is it? It's this part, right? Below the x-axis so far. That is this part, which means k less than 5/4 greater than 0. So we have proved that. Yeah, we got that. Here is all the knowledge we need to learn from this lesson. You need to know how to sketch the quadratic graph and to find the set of values where the fx greater than 0 or fx less than 0. And then you need to follow this process to solve the quadratic inequality. Well, that is the end of the lesson. Hope you enjoy watching it. Thank you.